Hello students, today we will solve numerical based on the concept of Routh stability criteria, okay, whatever we have studied. Look at this numerical. Here it is given that a system oscillates with frequency omega. I am underlining the important statement. The system oscillates with frequency omega if it has poles at s is equal to plus minus j omega and no poles in the right half of S plane. Okay, so determine the value of K and A so that system in figure oscillates with frequency 2 radian per second. Okay, see, the important thing is that here block diagram is given, okay, and in that block diagram you need to calculate the value of K and small a. These two are unknown. For calculating these two unknown, what is given here? Look at this. Here it is given that system oscillates. We know that when system oscillates, okay, so the system must be marginal system, that is marginal stability must be there. Okay, then second thing, here the roots are given. We know that when the system is marginally stable, so that roots are located on j omega axis. Okay, roots are located on j omega axis, and here what is given that these two are the roots. Okay, so s is equal to, it is given that plus minus j omega, these are the two roots are on j omega axis, and here it is given that frequency is 2 radian per second. Look at this, 2 radian per second. So indirectly here given that s is equal to plus minus 2j. Okay, so value of omega is given as 2 radian per second. Okay, 2 radian per second. Now see what we need to do. Here the block diagram is given. We know that this is actually g of s, this is h of s. Okay, so the formula for characteristic equation 1 plus g of s h of s is equal to 0. Okay, so I have substituted the value of g of s and h of s here. Then I have rearranged the equation to get the final form of characteristic equation. Okay, now what I will do, as the conditions are given that system is stable, because important thing, no poles in right half of S plane. It is given that no pole in right half of S plane means system is stable. Okay, system is stable. It is given with this statement. So what I will do, I will form the Routh array with the given characteristic equation. Okay, so I will form the Routh array. Look at this here, s cube term I will start, then s square term is there, then s raised to power 1, s raised to power 0. So I will start with the coefficient of s cube, so that is 1. I will skip one term, so this will be k plus 2. Okay, then again I will skip one term, so it will be 0. Look at this, 1 k plus 2. Okay, then it will be 0. Then I will start with the coefficient of s square, so this will be a. Okay, then skip one term, so this will be 1 plus k, again 0. Okay, so what I need to do, I will multiply this, so this will be ak plus 2a minus 1 minus k upon a. Okay, multiply this in minus this upon a, and what is coefficient of s raised to power 0, so this will be 1 plus k. Okay, now see, I know that as the system is stable, so all the elements in first column of Routh array will be positive. Okay, but here what is given that this system is marginally stable. Why I am saying marginally stable? Because here it is given that system oscillates with the frequency omega. So when system is oscillating, we are getting such type of response, just like the sinusoidal waveform. Okay, so we have studied that system is neither stable nor unstable, so it will be marginally stable. Okay, so what we will do, we know that when system is marginally stable. Okay, so we have studied the special case 2. In special case 2, we know that the complete row is equal to 0. Okay, so when complete row is equal to 0, what we are doing? We are considering the row just above the 0th row. Okay, and we will obtain the auxiliary equation. Okay, so actually why we are doing such thing? Because we have to find these two unknown a and k. Okay, Now we have got the Routh array. So according to the given condition, I know that these two rows are directly from this characteristic equation. Okay, so this A cannot be 0 because that is unknown term we need to calculate. Now this 1 plus k term, okay, k is also unknown. So this term, okay, this row must be 0. This row must be 0. So what I will do? I will write ak plus 2a minus 1 minus k is equal to 0. Okay, so this complete row is equal to 0. What I will do, when the complete row is equal to 0, the remedy over this we need to consider, or we need to form the auxiliary equation of the row just above the 0th row. So this is 0th row. So I will obtain the auxiliary equation as as square plus 1 plus k is equal to 0. Okay, from this as square plus 1 plus k is equal to 0. Okay, so now what I will do, I will arrange that equation. Okay, so first of all, see, I am arranging this equation. Okay, so what I will get a is equal to 1 plus k upon 2 plus k. Okay, see, I have arranged this equation in the form of a. So a is equal to 1 plus k upon 2 plus k. Okay, now I will rearrange this equation. So from this equation I will get s square is equal to minus 1 plus k upon a. Okay, so again I will rearrange. S is equal to plus minus j under root of 1 plus k upon a. Look at this. Okay, this is actually the quadratic equation. So I have arranged that quadratic equation because I have the roots. See, this data is given, s is equal to plus minus j omega. So what we need to do here, I will substitute the value of s here. So this s is nothing but plus minus j omega. So this will be plus minus j under root of 1 plus k by a, and I will put omega as 2. Okay, so this will be plus minus 2j. Again I will rearrange. Okay, so this will be 1 plus k by a. Now see, I have two equations. Okay, so what are that equations? So this will be number 1, a is equal to 1 plus k upon 2 plus k. Then I have this equation. Look at this jj with this imaginary term will get cancelled, and I will rewrite that as under root of, look at this, under root of 1 plus k upon a is equal to 2. Okay, so I have the second equation, that under root of 1 plus k upon 2. See here, equation number 1 and equation number 2. Okay, so I will solve these two equations, solving 1 and 2 simultaneously. Okay, 1 and 2. What I am getting? I am getting the answer as k is equal to 2 and a is equal to 3 by 4, that is 0.75. Okay, so we got the unknown term as k and a. Okay, so see, the important thing is here we have applied the concept from the data whatever it is given. Here it is given that system oscillates. It means that it is marginally stable. Marginally stable means root will be on j omega axis. Okay, so value of roots are given. Then we have substituted that value and we got the answer for unknown terms. Okay, so see students, we have completed the third unit, that is stability analysis. So I hope you got the concept. Thank you students.